quiz?
Yeah. So we could just open that up and talk through it.
Yeah, so this one was pretty easy. I haven't done the quiz yet, but the preparation assignments were easy. So let me know when you guys are at question 3.
You don't want to do question 1 and 2 together?
No, I can't. I don't want to. I'm just gonna skip those.
I can barely hear you, Scott.
How about now?
Yeah, it's better.
So I've got all the answers. I screenshotted it so I could see everything. All the answers that I put.
Yeah, my computer's taking a little bit to load.
All right.
I'm on question 3.
Okay. What about you, Chris?
What's that? I'm there. I'm ready.
Okay.
Okay, perfect.
It comes out to 100%.
Mhm.
Right. So the only if it follows the 3 rules, it's not over 100%. So yeah, it's true. Okay.
So
Alright.
would this be like 1/4 and then just divide that?
Yes, it's no, it's not. It's 0.45
Yeah, I was wondering.
because
just
the likelihoods are given in probability for each blood type. So it's just asking you what the probability of O blood type is, which is given as 0.45.
Yeah.
Just means that they're not equal in probability.
So the next one's 0.55.
Right.
0.55.
Yeah.
Because it's a 45% chance that someone will have it, and there's a 55% chance that they won't. Because that'll equal 100 or 1.
Does that make sense, Eric?
Say that again for question 5.
Okay, so question 4 is 45%, right? Or 0.45. So to equal 100, you have to have 55%, right? So there's 2 choices. They either have blood type O or they don't. So
Yeah, that makes sense.
yeah, you have the 45 and the 55 equal 100 together.
And then the next one.
Okay. Caroline Willis and her colleagues conducted a study in which dogs are trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Angle, one of the dogs, demonstrates the identification of the specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Okay, so the probability is 1 in 7, right?
Yep.
And you have to put it in decimal places, right?
So it's 0.143.
Is it going to mark it wrong if I put 0.143?
No.
I think that's how it should
Does
be.
that make sense?
Right?
Does that make sense to everybody?
Yeah.
Does that make sense, Chris? How we got 0.143?
Yeah.
Or 1/7?
1/7, right?
Okay. Yep.
Thank you for checking.
Just make sure you put it in decimal form because that's what it asked for.
Yeah.
Yeah. Okay. Question 7. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate?
I guess it provides strong evidence. Even though
It's not overwhelmingly strong, but it's
yeah, I know it's
The phrase that gives it away isn't that it's 22 out of 54. It's that it's very unlikely that they would do it. Because 22 out of 54 sounds like it's like 50% chance, right?
yeah.
but there was
50%. And so,
7 bolt.
but it would be you'd guess that it'd be 1 in 7 rather than that. I'm doing homework. I got to do this right here.
So then
Anyhow, you'd guess that it'd be 1 in 7. And so because it said it's very unlikely that they do that on their own, you put yes, it's true.
yeah, it provides strong evidence. Yeah.
So this provides strong evidence.
We're going to say strong evidence.
Mhm.
Yeah.
Because we were only, if it was probability, it'd only be 1 in 7. So we're significantly better than that.
Yeah. Okay, the M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of colors in a bag of plain M&Ms is given in the following table. If you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy? Do all these equal to 100%? I assume, yeah. So 0.13.
So the answer is 0.13, right?
Yeah. Yep. Does everyone agree?
Hello?
Yeah.
Yep, that's right.
0.13.
0.1.
And then do you just add all those up and then subtract it from 1 to get the green?
Yep.
I got 0.16.
Yep.
Yep.
So then the probability that it's not green is 0.84.
Yep.
Okay.
One more question.
Just 3.
What is the probability that the candy's not green? 0.84. And then, okay. So the rest are review.
What's that?
The rest are review.
Half of the observations are less than or equal to what number?
What do you think, Eric?
Half of the observations. Sorry. Oh, so this is regarding the last lesson, right?
Yeah.
I guess I don't know what the question's asking then. Half of
I'm
these
not following the question.
So
Yeah.
it's asking, it has a data set of
Right.
different people who took the ACT, right?
Mm-hmm.
Yeah.
And the numbers will range between the numbers that the ACT allows. So let's say between 15 and 36. In fact, this time it's 35 because that's the max it gives. And then it says, what number will half of them be below? So the median is the middle number. That's what that number means. So half of them will always be below the
So that's
median
it.
and
It's
half
24.
above.
Yeah.
That's why a box plot makes sense.
Guess it was too simple.
Yeah. So it'll be
So,
20,
so 11 is median, or is it 24?
24.
24.
Okay.
And then the top 25% is the first quartile, right?
No, it's the third quartile. The first quartile is the lowest, 25%.
Oh, it's saying the top after the 75%.
So it's 27.
Yeah. So 27 would be it.
Yeah.
Then
Between 0 and 4. It's positive. Probably. It's fine.
okay. Is everyone on question 13?
Yeah.
Yes.
Okay. So it's if the probability is high, then the probability is positive. If it's low, then it's negative. That's not a rule. Is that right? Everyone agree?
Yeah, if the probability is high, that's not one of the three laws.
Okay. Yep.
So second
Sweet.
from the bottom.
Yep. Let's submit it.
Hey, we did it.
We all got 100?
Yep, I did.
Yep.
Oh, I only got 2 right. I'm just kidding.
Okay, sweet. That one was pretty easy. And the homework is
Yeah.
just like that, by the way.
The homework quiz.
Yeah.
Well, I don't think the second half is going to be that easy.
What's the second half on again?
I don't know.
She tells us.
I got it right here.
Distribution, normal distributions.
Normal
Yeah.
distributions aren't very difficult either, though. It's just
Not-
looking at a bell curve. Bell curves are about as hard as box plots, so not that hard. Okay, sweet. Is that it?
Yeah, so now what you'll do is you'll take the whatever YouTube link this is and you'll put it in the group collaboration for lesson 4.
Okay,
And that'll be it.
sweet.